Hello, welcome to the Physics Options Evening presentation. My name is Dr. Bell. If you choose to take physics at Hatton, then we will be following the AQA A-level. The topics that we study in Year 12 are measurements and their errors, particles and radiation, waves, mechanics and materials, and electricity. In Year 13, we move on to further mechanics and thermal physics, fields and their consequences, nuclear physics, and astrophysics. The reason we chose the AQA course is because it has some really engaging topics that other exam boards don't have, such as the particles and radiation, and also the ability for us to opt in to the astrophysics. Throughout the course as well, there'll be a lot of practical work, including 12 required practicals that you carry out in pairs or in small groups and which you are being assessed on. At the end of the course, at the very end of Year 13, there are 3 exam papers. They're each 2 hours long and are approximately worth a third of your A-level. The first paper covers most of the topics that you cover in Year 12. That's measurements and their errors, particles and radiation, waves, mechanics and materials, electricity. But in addition to that, a couple of the topics from Year 13, such as periodic motion. The exam contains 60 marks of short answer questions and 25 marks of long answer questions. 60 marks of short and long answer questions and 25 of multiple choice questions. Paper 2 has the same structure, but it then covers the rest of the Year 13 content, including thermal physics, fields and their consequences, and nuclear physics. Paper 3 is a little different. It comes as 2 separate papers, one half being 45 marks and the other being 35. The first half is on practical skills, so all of those skills that you built up in the lesson by doing the practicals are then assessed. The second half, worth 35 marks, is on the optional astrophysics topic. The skills that you need to be successful on our course are curiosity. You need to be the kind of person that asks questions about the world around you, that you want to know how things work. If you're not curious and you find this sort of topic boring, then you will not find the course very interesting. You probably won't apply yourself and you won't do well. Whereas if you're a very curious person, you'll be wanting to ask lots of questions and you'll find it really interesting, which will motivate you. You have to be very logical. Physicists tend to be very logical people. They have to think in a logical way and follow processes. Your mathematical skills must be strong, and we'll talk a little bit later about how you must be taking A-level maths to get onto this course. You'd have to be very organised. As with all of your A-levels, there is a lot of work to be done, and if you let things slip, you can find yourself having to catch up. So being organised, keeping up with your notes as you go along, doing your homework on time, practicing lots of exam papers, having all your stuff organised in a folder, that's going to really help you to be successful. You need to be a really good problem solver. That could be from a mathematical point of view of looking at a question, or it could be with a piece of equipment in front of you, problem solving how to get it to work. You also have to have very good scientific reasoning skills. Students that have been on our course are usually find it very enjoyable. We've had students that have said it's great to be able to find something out for yourself. So, for example, you have a question about why something in the world is the way it is, and going away and having the skills to research that and find it out. Students in the past have said we work together as a team to succeed, and they've really enjoyed the team aspects of the practical work. And another quote, there is always something more to find out. I still have constant questions about physics and things that I'm learning. You never get all of the answers, and that's one of the things that we all find so exciting. There are many careers that you could go into. Not all physicists become physicists. You could get a physics degree and you could go on to be a research physicist. But equally, you could become an engineer. You could end up in hospitals working on MRI scanners. You could work in the laser industry. You could go into industries making mobile phones, in nuclear power, developing the next green energy. There are many careers you could go into. But lots of people with physics degrees go completely in different directions, such as working for newspapers as journalists, maybe as the science editor, working in the government. Many physicists are recruited at the end of their degree by finance companies because they know that you have good problem solving and analytical skills, and that's a great asset. So there are a whole heap of careers open for you. Frequently asked questions. Can I take physics without A level maths? Unfortunately, not. The maths content of our course is very, very high. And if you don't take A level maths, you will struggle. So you must get the entry requirements for maths and you must be signed up on the A level maths course as well as the physics course. Is there any practical coursework? No, we don't have coursework anymore. When the A levels were reformed, that was removed. However, there are 12 required practicals, and you gain a separate qualification called the Certificate of Practical Competency. It's a pass fail qualification, and universities will want to see that if you're going on to study a practical science course. Textbooks I would recommend. If you take the course, you will be provided with a course textbook that you borrow for the 2 years of the course. But the CGP revision guide for the AQA A level is very good if you're looking for additional reading. So your two teachers will be myself, Dr. Bell, and Mr. Simpson. Our email addresses are on the screen. So if you have further questions, please come and find us around school or drop us an email, and we would love to answer all your questions. So thank you. Goodbye.